just about to get Steve and Deborah on. So the way I look at it here, we've got what, 15, 16, 17 of us on so far. So we're going to try to have our program. Chris Copeland, there you can see on your screen, he's on the second row of mine. The blue hat, what's your logo on your hat, Chris? That a ball team? Anyway, he's going to give us a little update on his new all-in-one Wi-Fi thing.
Hey, Chris, you're on mute.
Yeah, he knows it.
So we're trying to do this from my wife's MacBook. So, yeah.
All right, well, if everybody will mute, and I will try to, and Chris, I'll call you up here in a bit when we get to your section. I'll try to do a screen share, and we'll do our little program. Oh, where did I put it? That one there. There we go. Well, welcome all of you to our Astronomy Club of Tulsa March virtual meeting. Being March, you never know what the weather's going to be like. And I discovered that Jinx School was not in session today. And at noon, it was uncertain whether we would be able to get in the parking lots or not. And so it just seemed to be wisest to do it this way. But our next one will be in April, I think the 9th of April. So anyway, welcome to you and our guests. And here's our agenda to the night. And we'll talk about some of the scheduled events, talk about some volunteer opportunities and some things that were done this past weekend. Our club has its 85th anniversary this summer. And then our friend Chris is going to talk about his astrophotography setup. And then I'm going to take a little bit of time, talk about the Messier Marathon coming up. And let Tamara share a little bit because she's the expert on it. And then when time allows, we've got going to talk about the astronomy picture of the day with an interview from the Night Sky Network with one of the co-founders of Astronomy Picture of the Day, which has been going since August of 1995. So I'll let you do the math, see how many days and pictures that's been. So here is our agenda. As always, check the website before you head out to something because sometimes we have to make changes. But tomorrow night, it looks like it's going to be good. We're going to have some telescopes set up at Oxley Nature Center. And I talked to the lady today, and she assured me that they have a tractor out there to clear the parking lot and that the road will be cleared. It looks like the sun has cleared it anyway. And they have a nice little warm-up room where you can go in and warm up, and they're going to have some hot chocolate and such. And we'll have a few telescopes set up to look at the moon, some of the brighter stars. And I'm going to bring a solar filter if the sun's not too low in the early evening, especially from 6 to 8. We've got about 4 or 5 volunteers that are going to help us, so that'll be good.
Hey, John.
Yes, sir.
My wife said that the Oxley's website does not list this event. She was wondering if it had been canceled. I told her I didn't think it had, but she was
told them that 4 times, and they assure me it's someplace there, and it's also on their Facebook. So it's
okay.
Out of my control. Yeah, it should be on there, but anyway, they don't do their website, so they depend on a volunteer. We have a guest night on the 26th, and I need several volunteers, please. We have a small Cub Scout group coming out that's one of our members from Owasso is going to bring his Cub Scouts down. And then a youth group of about 7 or 8, plus a couple of sponsors. So we will probably have at least 50 that night if the weather's good. So we'll need some volunteers to help with scopes. We'll need some volunteers to direct traffic to and from the parking lot next door. So that's the 26th of March. And the gates open at 7 p.m. Of course, that's on daylight time. Have our members' night on April Fool's Day. And then we have our Messier Marathon the following night. We'll talk about that later in our program. However, if it looks like the weather's going to be bad on this Saturday, we may move the marathon to the Friday. Give us 2 nights there to work with in case we've got clouds or something coming up. Then the Hicks Park event that got canceled in February is rescheduled for April the 7th. It's their 31st and 34th in Mingo, just east of 169 Highway up Mingo Road. They've got a nice community center there, and she told me she could turn the lights out on the tennis court and we could use that. And then our next Jinx meeting is going to be April the 8th. So that's what's coming up in the near future for our club. So I try to keep things posted on the website so you can check for new things, but we'll need volunteers for Oxley. Well, I've got volunteers for Oxley, but I'll need volunteers for the 26th. And I'll need volunteers for the Hicks Park event. You don't have to have a scope to volunteer. But here we see some of the things that we've done. Over the top there is our observing field from one of our public nights that was well attended. And the bottom right is a scout group that one of our members went to. In the middle is, where was that, Jack? The botanical garden that we went to on Veterans Day last fall. And then Kathy and a bunch of us went to the gathering place one really cold Saturday evening during the Christmas season. So we've had some other invitations. I turned one down at the gathering place because it was all daytime. Wasn't much we could do there, and they were doing other things that didn't really relate to astronomy, but they want us back this fall. Our club has its 85th anniversary coming up. I would like to see some things to do to celebrate that, but I'm not good on ideas things. So some of you that are creative really would like to do something like that. Most of our people that have been in the club before 2000 have kind of gotten where they don't do all this stuff anymore. So anyway, we'd like to have at least a nice picnic in the summertime. Maybe do some kind of public event to celebrate the club's birthday. 85 years, that's really something to celebrate. Last Saturday, we had 12 volunteers show up for a work day at the observatory. They cleared the road, they cleared the fence lines, all the brush and blackberries and all those kind of things that were growing around. I think we added a couple of 100 square feet to the observing ground up there, just clearing out the junk. Ben there in the corner, one of our high school students, helped me and Brad and I put together that metal shelf, and we moved things this way and that way and got it a whole lot more space in the room and accessible. Skip bought it's a mechanic's tool chest with things we can put our eyepieces and things in. so they're a lot more accessible. So we have a lot more room. Dana and there's Don and Dana. They worked on the dome. Dana's wife Bev worked on a lot of stuff, and so we got a lot done. And James tells me there's probably going to be some more work to be done this spring, but it'll be much more person-friendly space once we get everything cleared up.
Hey, John,
Yes, sir.
we had a little problem that night. We couldn't find the remote for the red lights in the observatory. Does anybody, I don't know how many of the people that were at the work day might be online, but does anybody remember where that ended up?
It's sitting on top of you see where Dana is?
Uh-huh.
There's a power receptacle just on the other side of the coffee table.
Ah,
That's where I said it.
okay.
You mean the little track light thing?
Yeah, because Ben and I looked for that thing all over the place. We never could find it. I'm not sure we looked there. So I'll check there the next time I'm out.
Yeah, they should have called me. I was just too tired that night.
That's all right.
Anyway, we had a good work day. Got more to do, but thank you all for doing all of that. So I'm going to stop my screen share and let Chris talk about his new all-in-one unit and all the fancy things that it does. So let me get off here. And Chris, I'll let you do your screen share and talk about.
Yeah, can everybody hear me pretty good? Good deal. So I do astrophotography more than visual, 9 times out of 10. So this is the ASI Air Plus. This is kind of a mini computer, and what this thing does for us is, first of all, it is a 12 volt DC or a 12 volt DC output. There's 4 ports. And I'm going to actually show you. I'm just kind of showing you what this thing looks like right now. So it's pretty small for what it is. So we got some USBs there, some Ethernet. So that's all this thing is. And now I'm going to show you kind of the bread and butter of this thing here. Let's see. All right. I'm using my wife's computer tonight, guys. I'm so sorry. It's a Mac, and I don't do Mac, so you just got to bear with me. Can everybody see that slideshow there?
Yes.
Yes.
All right. Hey, we're winning. So the ASI Air, I don't really read PowerPoint, so bear with me here. It's just a Wi-Fi controller and a power distribution box. That's all this is. Like I said, it's got 12 DC outputs for powering anything from our cameras, dew heaters, our filter wheels, everything like that for us. It has 2 3.0 USBs, 2 2.0s, and a gig Ethernet, plus a DSLR shutter release. I do not use DSLR cameras. I use dedicated astronomy cameras, so mine are all powered through the USB 3.0s. It has a 20 gig internal memory, but what I do is I use an external hard drive. I use a 1 terabyte external hard drive to expand that, so I can really capture all my data without really having to move it over. This has a 20-meter Wi-Fi range. What that allows me to do is my mount, I am running the Los Mandy G11 mount. So I can hook that up to a tablet, for example, and I can go inside and monitor everything on my imaging train from this ASI Air. And as you can see from this drawing, this is kind of the old school way, this top version right here with a laptop that had to be out there, all the cables that had to go with it. We really eliminated the cables through the ASI Air, not having to run as many for power consumption too with the 12 volt, that really helped. So this is what it looks like on a tablet for me. So what we're looking at here is in the top left corner, we're looking at the guiding. So this is a guiding histogram. And then all these different menus right here, we can see everything on here from our camera to our filter wheel, to everything. And I can actually set up however I want to run it through my auto run. I can set up how many images we're going to take on what filter, what channel, and then it will automatically actually switch. So I really, the only thing that I have to do is when we do the flip, I have to go out there and kind of mess with that. But past that, I can set this up and it will start running all night long for me. And it, we can set it up to take 20, like 6-minute, pictures, and it'll just keep going. We can do all our cooling on our cameras from all of this. And we're going to see some more of that here in just a second. So this actually will connect and hook up through our mount, and it will allow me to kind of polar align also. We're going to look at that here in just a second. Let's see. So this is a polar alignment for us. So what this does, this will take a exposure and it's going to plate solve. If y'all don't know what plate solve is real quick, it just takes a picture of the night sky, kind of uses an algorithm to tell me how far off of Polaris we are, gives me the adjustment to make, and then it gives me my total error down here. And then we just keep doing that until we're happy. So you see this little smiley face. So polar alignment, especially for somebody like me, I have to set up every time I go out. I do not have a dome or anything. So this makes setup for me what used to be a 15-20 minute process. I can get to within about half to 1 arc second of error in about 3 minutes. And John, I think you were out there the last time we did that. And this is, oh, go ahead.
Go ahead.
Oh, so this is what it looks like when it tells you did it. So on this one for me, the plate solve took 2.2 seconds, and the total error was, I think, half an arc second for me. So that is pretty accurate. That's good enough for me. On focusing, this is another one of the programs in it. You can take an image, you can see it through the tablet right then. You can make your corrections right here, live time, and then you go back, take another image. Once you get your focus, you're done. And this is all through the Asi Air. And then the guiding is also displayed, the histograms displayed real time. And there we go. This is just another photo for you guys. This is kind of what it looks like. So on here, if we were to look, there's a lot more I tried to get as many photos as I could without just killing you all with the details. There is a lot of ability here as far as what you can do with the scope and the filter wheel and how you guys can set that up. You can also see a pre-stretched image, such as this right here. We're looking at a pre-stretched image. This ASI Air will also live stack the images for you to see if you need to make any type of corrections, any type of recentering. This also has a program to center your image. You will simply come over here if you want this part of the image to be the center. You can click it, hit recenter, and it will move the whole frame. It'll actually move your mount to recenter on that point right there, and then your tracking will be based upon where you clicked on, whatever. Really, the stars is where you need to click on. Some people try to click on a part of a nebula. It doesn't really work that well, what I found. The transferring the data, like I said, is really simple. It's a USB Type-C or an expanded micro SD card. I use the Type-C with the expandable hard drive. It's almost instantaneous. I don't even notice. When I have 400 subs to transfer, I can do it in about 30 seconds. So the ASI is an all-in-one system. It's very easy, and the cost is about $300 for this.
Wow. So
it's pretty cheap for what you get. I could not ever imagine going back to astrophotography without ever having this.
Where did you get it?
I got it through High Point, OPT, Gina Astro, any places like that carry that.
Just $300. I was thinking way more than that.
Nope, it's $300, and I took, you know, where I used to have so many power sources and 12 volt, you know, inverters for, you know, all your heat, your dew heaters, your filter wheel, you know, all these different things are now all ran here and they're all dedicated. This has a little light above it. So it'll actually tell me when they're turned on. So I can actually have my camera here. I can have my guide camera, a dew heater, and my filter wheel. And I can run them all through individual. So I can turn them on and off. I can run my camera's cooling, everything like that through that.
How do you power it?
It has a 12 volt power on the side here. Trying to get that to go. It don't want to do it. Just one little 12 volt. That's all that takes.
So you use a jump battery or something?
Nope. Where I do, I just run it an extension cord, and then I have a power strip.
Okay.
Chris, does that have plate solving software built into it?
It does.
Wow.
So if you wanted to do strictly visual, you would have to hook up a camera to be able to recognize that, which we did actually a couple Saturdays ago at the dome. We pointed it at the sky, took a photo, it recognized where it was, and we kind of used it to find a few targets.
You mean like through a guide scope?
You can use a guide scope or you can use a dedicated astronomy camera.
Right.
It likes anything.
Last thing is, can you show us how you mounted the external hard drive to that, or kind of explain it?
Sure. So this is my external. I'm using this software. I'm sorry, guys. My wife's got a blurred background software going. So this is the external and this is that. And I put a piece of Velcro and I just stick it right to the top of it, just like that.
Do they need to be cabled together or anything?
They do. It's just a type
Yeah.
C to type C. And
Okay.
it plugs in on the side and on the back side.
All right. That's all my questions. Excellent.
You can also use a USB flash drive in that.
Yes, you can. I just don't, but yes, you absolutely can. And it also has a spot for an expandable SD card.
Would that, you know, we've got our big dome scope. If you hooked it up to a camera there, would it tell us how much off or on we are for polar alignment?
Yes, it will.
Actually, it doesn't work on our dome scope, on our mount.
Oh, it won't.
It's an old mount that it's a Meade mount that Skip can probably address the history of it. But I've tried it. And
Does it not have an ST4 port?
It's a 2006 telescope.
It does have a guide, it does have a guide input, but I've never used it. We've talked to it with the computer over RS-232 a few times, and that does work. But I don't know if the ASI Air supports it or not. It's a Meade RCX 400 from about 2005.
Does that polar line through the primary telescope or the guide scope?
It's permanently mounted, so we only had to polar align it once theoretically, and I attached basically a guide scope to it temporarily. I use that, but the telescope itself, the field of view is way too narrow to use sharp cap to do the polar alignment, which works on the same principle as this probably, but it needs about a 2-degree field of view.
Yeah, well, I've been using a pole master, and that takes quite a bit of while to get that thing to center it up.
Well, the problem with the pole master is we didn't have a good way to attach it to the optical assembly.
Okay.
Okay, guys, we're gonna kind of move on. Chris, if you'll unscreen share, and we can talk later after the program's over if we want to. So you're there, Skip, or not Skip, Chris?
Yeah, I'm trying to get it off. I can't get it off now. Let's see. Did that work?
Didn't work.
Oh, you turned
here.
off your video, but you're still screen sharing.
It should be at the very top of your screen. There's like a minimized toolbar. At least that's how mine is.
I don't know. This is my wife's. I don't know.
I have a Mac and the screen share is at the bottom. It's a green.
Okay, when I click on this, James, it came up and said, this will stop other screen sharing. Do you want to continue?
Go for it.
Yeah, do it.
Hey,
There you go.
well, you're still on there, but I think we can do what we're doing.
I'll keep looking.
That's all right. So I can share mine. Do y'all see it again?
Yep.
Yeah.
So there's Chris's little thing. You can see it better here in this picture. Got all these little ports in it. A whole lot better than the 60-foot USB power extension I run out my kitchen window, I'll bet. Oh, Messier Marathon is coming up. It's an all-night quest to discover deep side treasures in the night sky. And I got this from Night Sky Astronomy Picture of the Day. It's I've forgotten the guy's name, Tuffershe from The World at Night, and it shows a whole bunch of people at a Messier Marathon. There's the stovepipe or horse in Scorpio, big dark nebula. So the goal is to start as soon as you can see stars in the west at sunset. Try to find a couple of objects before they sink into the horizon and work your way through the night to find as many of the 110 Messier objects as possible. Charles Messier was a French astronomer. He lived near Paris. He had about a 4-inch refractor. He loved to find comets. Now, if you've not looked for comets before, they don't look like the long stretchy tails that we see once a decade from really nice ones like we have for Neowise and the one we had Leonard that we had this year. Usually it's just a little fuzzy patch of light, but you know it's not a star because it will change positions from one night to the next. So as I read up on this, he discovered 15 comets in his lifetime, which is pretty good. But he kept running into these other things that looked like little fuzzy patches, but they were always in the same place. And he didn't want to waste his time looking at them again. So ironically, he made a catalog of things he didn't want to look at, which are the things we really like to look at. He started out in 1758. He cataloged 102 eventually, and then people got to going back through his books and added a few more. So there are 110 objects in the modern Messier calendar or catalog. They're star clusters, they're nebula, they're galaxies, and they're popular topics. If you've been to any public stargazing, you have probably seen some. Some of them, many of them are visible in binoculars from dark skies. In fact, there is a binocular certificate for finding them. And you can get a Messier certificate for finding as many as 70. Or you can get a certificate with honors for finding all 110. And that was the first thing I did after I got my 6-inch reflector way back in the 70s was to do my Messier certificate. In fact, that's what got me hooked on astronomy. I went to Astronomy Club of Tulsa meeting. I commuted here from a little town called Okima. And we went out by Keystone Lake someplace. And Tom McDonough, a few of you know him. He was in high school with some of his friends. And I had discovered something with a little 60 mm refractor I was using, and he said, "Oh, that's M11." Oh, 11. Well, it must be 11 of them. And he informed me there were 110, so I had to find them all. Anyway, the goal is to find as many as you can in a single night. I'm not sure what the club's record is, but I think it's someplace around 104 or 105. Excuse my voice.
Hey, John,
Yes, sir.
I just wanted to mention, I don't know if everybody's gotten to know this or not, but you know, the Astronomical League also has what they call observing challenges, which are sort of, they're not the observing programs that are permanent. These are more, kind of, they do these in seasons. They usually try to have 2 or 3 every year. And they just came up with one, the Astronomical League Galaxy Season Observing Challenge. You can't do any observations before March 1st, and you have to finish by June 30th of this year. I won't read off all of the
Sounds like
requirements.
something you need to send me a link to, so I can let. the
I'm sorry,
members
John,
know.
I couldn't hear you.
Send me a link to it, and I'll let the members know. Put it on you can put it on the Facebook. We put it in newsletter.
I'll just put it in the chat and also send it to you.
Okay.
Okay.
All right. Officially, you're not supposed to use any go-to things, but anybody who's bought a telescope in the last 8 to 10 years, you can't. Most of them are moved by motors and control pads. So you can move your scope to that section of the sky and then star hop from one object to the next. We had a nice article about that in our January, well, I think it was November newsletter. If you look in the March newsletter, I put a link to it. But it shows you how to find your field of view for an eyepiece, you know, and then move it until you find your object. So we'll see how that all goes. It's an all-night adventure. So you need to be sure and bring you some things to keep you sustained through the night. Tamara had a great idea of us bringing some desserts or snacks that can be shared. So a comfortable lawn chair is nice. We can come in, warm up in the classroom, all of that kind of things. But it's for members only. It's not for kids. You know, if your wife wants to come out with you or your husband, that's fine. But you know, you're probably going to be there most of the night. So you can send me a RSVP mainly so we know how many people are going to be there. Tamara, you want to talk about your dessert idea or whatever it was? I've forgotten.
Yeah. Can y'all hear me okay?
Yes.
Okay, good. In past years, we've had our Messier Marathon out at an observatory called Tuva, which is down near Muskogee. And our host, Ron and Maura Wood, hosted us every year, and we would have a potluck dinner before the observing began. And, you know, we would just eat dinner and socialize for a bit. But unfortunately, they've had a fire. I guess it was some kind of electrical fire in the building that they used for a classroom and that we would use to eat and come in and warm up and take naps in. So we can't have it down there this year. Now, we thought about doing a potluck, but the observatory really is not equipped for a potluck dinner to the scale that we did at Ron and Maura's place. But I thought each of us could bring a dessert to share or some, you know, simple snacks. Like if you want to bake some cookies or some sausage rolls or whatever, or bring a crock pot of chili you know, just simple snack fare, drinks, things like that. That's always really nice. That way we can have somewhat of a potluck before we do the observing, but it just wouldn't be as big as what we had down at Tuva, because we're just really not set up for that.
Won't be a whole
But
meal.
huh?
Won't be a whole meal, just, snacks. You can come in, get a snack during the night, so.
Yeah.
Yeah.
So, and I just kind of ran that idea by John, and he seemed to think it was a good idea. So if y'all want to bring a snack or drinks or desserts or something to share with everybody, you're more than welcome to. So,
Understand you've already had a pre-order for your rum cake.
yeah, I have. I've been, I will be sure to bring one.
Okay, that's kind of Tamara's specialty, rum cake. All right, I'm gonna go on here now. But those of you who are on tonight, you can send me an email. We'll start making lists of who's coming. I'm gonna make a packet. Tamara sent me some more stuff today and send a link out to it somehow. So in the last newsletter, the March newsletter, there's some links on there. There's a multi-page, I guess it's 21, about 31 pages. It's got charts at the top that show you the sequence to search for the objects, tells you which ones and what time you need to start looking for them, and so forth. And they're arranged more or less by right ascension. But so over here on this side is a section of the constellation Auriga, the Charioteer, and you can see the three globular clusters, M37, M36, M38, and it says, they're all together, so their number, the sequence number by it, 18, 19, 20. So you can print those out. Of course, a lot of people have apps on their phone that they can use to find things. Or I've got, one of the star charts from Sky and Telescope. But most of these things go down to 7th magnitude or so to help you find things with your finder scope to get them lined up. It's got a place to write down the time that you found it, little note. You don't want to spend too much time on each one. I don't remember which one it is, Tamara, but there's one of them up there that's a Big Dipper that's just 2 stars. I spent way too much time looking for them. But anyway, that's what it's all about. And there's a number of links in the March newsletter, and I will try to send out some more, or you can look things up online. But hopefully we'll have a good night. As I said, the plan is for Saturday night, April the 2nd. But if the weather looks like it's better on the 1st, we may do it on the 1st. So that's our Messier Marathon quest. Any more questions about that?
John, when do you need your RSVP?
Anytime you want to send them in, I'll send out a paper next week that, tell people to get started. I'm just going to make a spreadsheet so we'll know who's coming. But anyway, that's the plan. So I hope to get to go. I've arranged my schedule so I don't have to drive the church van the next Sunday morning. It mightn't be safe if I've been up all night. So anyway, okay, our program tonight. What time is it? Oh, we've got time to do this. Is from Astronomy Picture of the Day, which has been in operation since June of 1995. And it's from Night Sky Network. They're going to have an interview with the co-founder, Jerry Bonnell, but I'm going to show you a few things about night sky network if I can figure out how to get out of this. Oops, that's not it. There it is. Here's a night sky network, not night sky, astronomy picture of the day. This one was a few days ago. They have all sorts of images on there. They have amateur photos like this showing the Andromeda Galaxy, and you have some really amazing stuff. This is part of the group called The World at Night. People all over. If you scroll down,
John, I'm sorry to
What?
interrupt. We're still seeing the PowerPoint, or at least I am on my screen.
oh, okay. Let me try again. Thank you. Let's do that. Is that better?
Yep. Now we see the APOD site.
Thank you, ma'am. I'm not blog savvy like you are. Okay, great. Good to have some people less than 30 to keep us in line. All righty. Anyway, there's always something at the bottom about the pictures and links you can click on and all sorts of things like that. One thing I like to do, if I try to look at it almost every day, but if I miss something, I can click on calendar down here and I can see all the pictures that came up for the month of March. They had an interesting one today of a rainbow overhead. Where was it? It was a tropical area. Oh, in Sicily. But it was ice clouds overhead. So essentially it was a sundog that was overhead. That one was kind of neat. They also have well, I clicked the wrong button. They have a search here. If it will go there. And I can say, I want to see comets. Comet Neowise. And then click find the words. And there's pictures of the comet. That was the one we got to see. Well, 2020 is when it was around. But there's a nice diagram of the nucleus and the tail and the ion tail and all of that good stuff. So I taught astronomy at the high school, and kids would use that to make their reports to find something to kind of make things look nice. So it's a nice search engine. It doesn't always come up with what I want, but you can find things. And it goes all the way back to the early ones. I found something today, if I can find it again. May. No, that's not it. Wrong date. Anyway, I found one that lets you had a random astronomy picture of the day. It would just, you click on it, it would randomly pick a picture for you to look at, which I thought was kind of neat. So there's the 8 burst nebula. There are a lot of them are Hubble Space Telescopes, some of them amateur telescopes, eclipses, all of that sort of stuff. So it's a long archive of pictures and you can look up things. So let me unshare this one. Let's see, Miss Lauren. Try to reshare. Go over here. gonna have to copy the link. Stop share. Reshare this one. And hopefully I'll be able to paste the link in here to our video.
Such webinars to the Night Sky Network. So this is my first time.
Can you hear him?
Yes.
Yep.
Okay, I didn't know if I clicked all the right buttons to make that work. So this is Dr. Jerry Bonnell, and he's going to talk about the Night Sky Network, and I'll make it full screen when I get it running here.
Bob Nemiroff and I have been doing Astronomy Picture of the Day, a website run out of Goddard Space Flight Center for a few years now. I think it, as mentioned, in 1995 is when it started. And tonight, I'd like to show you some pictures from that website that we featured in 2021. So, and I sort of like the travel log metaphor. So I think I'm going to try to do something like postcards from the universe. Pictures from Astronomy Picture of the Day, 2021. The one on the title slide here is as it says, Apollo 14 heads for home. I wonder if it looks familiar to you. There's actually a very famous image from Apollo 8, the Apollo 8 mission of Earthrise, the Earthrise over the limb of the moon. This is a similar one from Apollo 14. So what you're seeing here is, well, Apollo 14 actually would have been in 1971. So that would be 50 years ago. This 2021 would be its 50th anniversary. Apollo 14, I think, was Shepard, Rusa, and sorry, if I can check my notes here. Oh, Mitchell was the lunar module pilot. So this is, but this is all three of them in the command module coming around the far side of the moon. And as they orbit around the moon, they see the crescent Earth rising there on the limb. So that's the far side of the moon, the unfamiliar side in the foreground there. They see it rising because of their orbital motion, right? When Shepard and Mitchell were actually on the lunar surface, the Earth just hangs in their sky. It's more or less steady at a spot in their sky. But because of the orbital motion, the moon is locked in tidal rotation, and because of the orbital motion, they can see the Earth rise. Anyway, Apollo 14 heads for home. It's a good start to the travel log here. So let's travel to France for a moment. This was, I thought, an interesting submission late in 2021, but it's actually a photograph of the summer sky, a sort of late night summer sky, from a plateau in the French Alps. So this is at substantial altitudes, say maybe 7,000 feet or so. The sky's very clear. The night sky is very clear here. The foreground is lit by moonlight. So this is a picture taken near moonset. And these two friends have been hiking through the Alps for the day, and they're admiring the view. It's an interesting view, and it strikes me that it has it has a literally extragalactic perspective. So I'd like you to look with me for just a minute. It's also very much, it also reminds me, it's very evocative of what you would see with the eye if you were there on this hike. This is the Milky Way. You can sort of see running down the left side of this view here, of this frame here. So this is Cassiopeia. This is Perseus down here. So this is the stars in the plane of our galaxy, the Milky Way. Right above them here, I see another galaxy, the Andromeda Galaxy. Also, if you're a fan of the night sky, I bet you've seen the Andromeda Galaxy. That's it's an easy naked eye object, an easy extragalactic naked eye object. 2.5 million light years away is how far you're looking there. I think the photographer Martin Lafranc realized maybe only after he made this image that right down here, right between the two friends, is another galaxy, the Triangulum Galaxy. M33 is this very fuzzy spot here. So these basically are the three galaxies in the local group, the three largest galaxies in our local group. M33 is the smallest, Andromeda is the largest, Milky Way is the middleman in size there. Quite an interesting extragalactic perspective, I think. Had the two friends, let's see if we can do this. Had the two friends actually been on that hike 5 billion years from now, they would have seen something like this. The very top frame here is an illustration, not a photograph of a horizon, and this is the Milky Way galaxy, and this is what the Andromeda Galaxy would look like about 5 billion years from now, when Andromeda and the Milky Way galaxy begin to merge. Andromeda is headed for us, although it will take a while to get here. The sky will look really spectacular when it does get here. In fact, the third galaxy in the photograph, the galaxy between the two friends, was the Triangulum Galaxy. That's this frame here. A telescopic image of Bernard Miller. I really don't have a good image to illustrate this, but ultimately, of course, the Triangulum Galaxy will join the Milky Way and Andromeda in a merger. I just note the Milky Way plus the Andromeda Galaxy, you would probably call that galaxy Milkdromeda, for what it's worth. And I tried to think of something to call the three galaxies when they were all merged 5+ billion years from now. So I went for Trimilkdromeda. I don't know. I expect there are people that could do a better job. Have a few images of Mars here, sort of snapshots from the Perseverance mission. Mars 2020 mission actually landed on Mars in February, I think, of 2021. This top one, Perseverance, How to Land on Mars, is actually a snapshot of the Perseverance itself being lowered to Mars surface on these 3 cables from the descent stage. The descent stage is rocket powered. So it's a rocket powered sky crane, if you can imagine, was lowering this rover down these cables to the Martian surface. These cables, I have in my notes here, these cables are about 7 meters long. And at this point, which is actually a frame from a video that's being made with a camera on the descent stage, the rover itself is about 2 meters above the surface at this point. You can see the rocket engine exhaust is blowing the dust around the surface of Mars. In Jezero crater was a delta near one side of Jezero crater was the landing site. This is an electronic umbilical signal cable. In fact, it's connecting to the computer on board the Perseverance rover, and it's almost a selfie in the sense that this image is being recorded by the computer, being transmitted through this cable to the computer on the rover for later broadcast to Earth. Of course, after the sky crane drops off the rover on the surface of Mars, these cables are detached and the descent stage flies away nearby and crashes far enough away so as not to contaminate the landing area. Just to prove, well, I'm sure everybody's seen images from the Perseverance Mars rover mission. This is say a month later or so. This is a selfie, Perseverance rover, and this is Ingenuity, the helicopter, the little Mars helicopter it brought with it. So, a few snapshots from Mars. This top one, we're still hanging out on Mars here, except this is the Curiosity rover. It's a mission that's been operating on the Martian surface since 2011, and I just thought this was an interesting shot of clouds on Mars, night shining clouds on Mars. This butte in front here, this sort of layered mound, is called Mount Mercou. The Curiosity was parked nearby. In this image was made near twilight. And so the sun has set, but on Mars, as seen by the Curiosity rover, but the clouds are shining still because they're very high altitude, extreme altitude clouds, and still in sunlight, even though the ground is in shadow. So on Mars, those clouds would probably be carbon dioxide ice, dry ice, crystals, very small, as I say, at really extreme altitudes. We have that same sort of thing going on Earth. The bottom panel shows you Northern Summer Twilight by Justin Anderson. It showed the clouds that you see, these silvery, wavy clouds along the horizon in the distance there, are not dilucent clouds, night shining clouds on Earth. They're water ice, though, I think. And we tend to see them on Earth in the summer months at very high latitudes. Once again, the sun is below the horizon. And you see these clouds shining because they're still in sunlight. They're at such extreme altitudes. I guess one big difference might be that in Justin Anderson's view, all these little green spots of light are fireflies. Probably not fireflies on Mars. When I was putting this together, I think I had trouble getting away from Mars. But let's do a few more Mars pictures. Actually, the one at the upper right is not so much Mars, but it does look like it. On Mars, the sky is this reddish brown because in the Martian atmosphere, the Martian atmosphere is dusty. There's very fine dust on Mars. The dust is iron oxide. That's rust. That's why the dust it colors the sky sort of a reddish brown, the Martian sky sort of reddish brown. And on Earth, of course, the sky is blue, but in this, the upper picture here was taken in the Swiss Alps at a ski resort on planet Earth, and the dust that's in the atmosphere that's scattering the blue light and turning the atmosphere of Earth this reddish brown is from the Sahara. It's the Sahara dust storm blowing across the Swiss Alps there. Looks like Mars. Another image that caught my eye was also a little like Mars by Robert Barsa here. This is it's a little planet projection, it's called. It's a 360-degree panorama with the nadir at the center. So it's been projected, and this is the horizon, and this is the sky. It's an all-sky panorama. Robert Barsa's at San Pedro in Chile, in the Atacama Desert. And the Atacama Desert is what the foreground here is. Looks a lot like Mars. You have to, it's a southern hemisphere sky, so I bet you do recognize some things in the sky, but for example, this is Orion. Although from the southern hemisphere perspective, you might notice it's upside down. So there's a Betelgeuse down here, Rigel up here. The large Magellanic Cloud, small Magellanic Cloud, good southern hemisphere objects. And actually in Barsa's photograph, he did get Mars as well. This is Mars in the night, in the southern night. Oh, we're still cruising through the solar system here. I guess in 2015, maybe Rosetta mission was launched in 2014. Arrived at Comet Churyumov-Gerasimenko, and this is a photograph from the Rosetta spacecraft, the European Space Agency's Rosetta mission spacecraft. It's actually it's a photograph from the lander, the Philae lander on the spacecraft, which is still attached to the spacecraft in this picture. This is the sort of the sun glinting off the solar panel, one of the spacecraft solar panels. And at the very top, you see this sort of double lobe nucleus of Churyumov-Gerasimenko. If you get tired of saying Churyumov-Gerasimenko and you don't want to call it Rosetta's comet, you can always call it Comet 67P. It's a P for periodic. It's the 67th on the list of periodic comets. And it has an orbital period of 6 point something years, 6.4 years, something like that. And so this Rosetta mission arrived, as I say, I think in 2014 or 2015, stayed with the comet, explored the comet. The Philae lander actually landed on the comet, and the Rosetta spacecraft was actually driven down to the comet during its last perihelion passage. But it's come back. Its new perihelion passage, I think was in, its most recent perihelion was in November, early November. And so the comet was back in our skies. This is a nice picture from Rolando Lacustri of Rosetta's comet 67P while it was in the constellation Gemini. These are stars in Gemini, and I think this is light coming in from Pollux there, Beta Geminorum. one of the two bright Gemini twin stars. So when you see this comet, when you see photographs of this comet, this is actually the resting site of the final resting site of the Rosetta spacecraft and its lander as it comes by the sun again. There's actually another comet, fairly bright, although possibly not certainly not a good naked eye comet in the sky in 2021. But as we continue through the solar system here, so this Comet Leonard. Comet Leonard was discovered early in the year, and this is a picture of it. It's getting brighter now. I think it's near its perihelion. It's certainly near its perigee, its closest approach to Earth. In December, it's in the foreground, but fortuitously along the line of sight to these two interesting galaxies. This is one that's popularly called the Whale Galaxy, because I guess it looks a bit like a whale, especially in this picture. And this is the hockey stick galaxy, two interacting galaxies with the comet along the line of sight, right? The comet is actually a few light minutes away in this image. The galaxies are like 25 million light years away, so they're quite in the distant background. Comet Leonard has no spacecraft associated with it, and will not. This is Comet Leonard, unlike Churyumov-Gerasimenko, is not a periodic comet. It's on a hyperbolic orbit. It's a one-time. I think its perihelion, its closest approach to the sun, will be in January, and then it's out of here. And if you think about it for a minute, it's hard to plan and execute and launch a mission to a comet unless it's periodic and you can actually plan over a period of years and match orbits with the comet over a period of years. The comets that just come in, swing around the sun, and go out are hard to catch. It's going to be hard to catch for a spacecraft. Well, we'll get out of the solar system here eventually. This is well, it says 50 light years, 51 Pegasi, and there is 51 Peg circled for you in the top center here. It's a picture of the Observatoire de Haute-Provence in France, where Michel Mayer and Didier Queloz worked and discovered the first exoplanet around a sun-like star, around the sun-like star 51 Peg. So their discovery would have been in 1995. Actually, that's a good year. That's about the year Bob Nemiroff and I started up with APOD. Not that that was anywhere near as profound as the discovery of the planet around 51 Pegasi. 51 Peg B was initially the planet's name. It's, of course, at this point, there are 4,000 plus known exoplanets. Many of them discovered by space missions, like, well, many of them discovered by the Kepler mission, This one obviously based on discovered by ground-based astronomers. 51 Peg was detected by measuring the Doppler shift, the wobble that the planet produces on the star spectrum as the planet orbits. And so it was, I think you can time it, you can determine its orbit, you can estimate its mass, the mass of a planet. And 51 Peg B was estimated to have the mass about, I don't know, about half, at least half, maybe more than half the mass of Jupiter. It orbits 51 Peg every 4-point-something days. So it's a sort of a Jupiter-sized planet that orbits its parent star closer than Mercury orbits the sun, much closer than Mercury orbits the sun. And it turns out to be sort of the prototypical, archetypical example of a hot Jupiter, which now that we've seen about 4,000 exoplanets, hot Jupiters are relatively common, not unusual, not exceptional for planets in planetary systems. Incidentally, I think Meyer and Kalos got I think that was the 2019, they shared the 2019 Nobel Prize in Physics for this work with James Peebles. A little farther away, if you're going to venture a little farther away than 51 Peg B, I'd say you could get to M13, the globular cluster. It's probably 20,000, 30,000 light years out in the halo of our own galaxy. And this is one of the brightest globular star clusters in the constellation Hercules, known as the Great Globular Cluster in Hercules. It's a very nice image of this really dense sphere of stars here. Now, these stars that you see with spikes around it are definitely in the foreground. This is a ball of a few 100,000 stars, let's say, in a diameter of about 150 light years. At the core, yeah, well, you can see the individual stars resolved in the image around the outside of the cluster here. But at the core, the density of stars is rather large. In fact, I think if you took a cube 3 light years on a side and put it at the core of a globular cluster like M13, you could probably count 100 stars within that cube. If you took a cube 3 light years on a side and put the sun at the center of it in the solar neighborhood, you wouldn't find any other stars. The closest star system to the sun, Alpha Centauri, is 4-something light years away. So it's very dense in the core of that globular cluster. Many years ago, a naturalist photographer, wildlife photographer, Roger Hopkins, sent this image to Astronomy Picture of the Day. It's an image he took at a wildlife preserve in upstate New York. I wish I could name it. Maybe Dave would recognize it. Of what he described it as what he thought sunset would look like if he lived on a world in the center of that orbited a star in the center of a globular cluster. Then I thought it was pretty clever. As you can see, as the sun is setting and the stars are beginning to come out, the sky is very densely populated with stars. I think what Hopkins has done here is he's photographed a flock of birds flying above the water here, and manipulated the photo to turn the birds, the black dots of the birds in the stars, a flock of stars. Sunset in the middle of a globular cluster. Hanging around in the plane of our galaxy, you could travel to star-forming regions like M16, the Eagle Nebula here in one of Adam Bloch's nice images. This is a cluster of stars inside its sort of natal molecular cloud that the star cluster formed from. And you can see the stars as the stars, winds and radiation from the stars sort of sculpt away and carve away at the dusty regions. They compress the gas and do all these dense features. Stars are forming inside these features. New stars are being born here. There's a famous Hubble image called the Eagle's eggs of this particular formation right here, and another famous Hubble image of this extension here for star formation. In this the image here by Robert Eder, Eder has taken out all the stars that he can see. He's digitally processed them away to leave just the star stuff, the star forming material. In a nebula IC 443, it has this famous feature in it called the Elephant's Trunk Nebula. And although Eder has taken out all the stars he can see, there's still stars forming down inside the elephant's trunk here. Which I guess you could see if you could look in infrared light, you would see some indication of the star formation going on inside there. These features as well. I only recently learned that the popular name for this is the elephant's trunk in IC 443. This is the caravan. These sort of star forming pillars are popularly known as the caravan. So elephant's trunk and caravan. If you wonder, well, let's look at it this way. If you were just in interstellar space near the sun, you could probably count one atom of hydrogen in a cubic centimeter. If you were to fly in your starship through one of these regions we see as these nice nebulae, maybe you would count in a cubic centimeter, maybe you would count 10,000 atoms of hydrogen. So they are quite a bit denser than the local stellar neighborhood. That's why we see them in, we still see the star stuff, we still see the nebulae. Of course, if you were to try to count the air molecules in the room you're sitting in a cubic centimeter of the room you're sitting in, you would count 10 to the 19th or something like that. So you would count 10 billion compared to 10,000 compared to one in our neighborhood. You were wondering how dense that was, if it would affect your travel plans at all. You have any travel plans to go here? I don't know. I'm a big fan of Star Trek, for example. And if my starship were going anywhere near here, I would put the shields up, as it were, because this is the Crab Nebula Pulsar, and it's been imaged in by the Hubble Space Telescope and by CX Chandra X-ray Observatory. So this is a mix of optical and X-ray imaging of the Crab Nebula. pulsar. It's, and I would say this distance through this inner ring here is about a light year. So this is a pretty enormous, still a pretty enormous, basically a particle beam weapon almost. The pulsar is spinning 30 times a second. Its magnetic field is dragging is forming this torus of energetic particles. Relativistic particles are shooting out the beams perpendicular to the rotation axis, or along the rotation axis of the torus. Of course, the Crab pulsar is, and the Crab Nebula is a supernova remnant. The Crab pulsar is the core of the collapsed core of a star that exploded around 10,000 years ago and was observed in records. There are records of it when its light reached Earth, and of course the nebula is the sort of expanding debris cloud. Shields up for a tour of the Crab Nebula pulsar dome. Yeah, one of the problems with sort of using astronomical images to tour around the universe is, well, is sort of the vantage point is not, you're not really in control here. But I like this pair because, well, consider this. An external galaxy, the Whirlpool Galaxy M51. Very bright galaxy, once one of the original spiral nebulae that people would make drawings of. You can see the spiral structure in a large telescope and see it visually. You don't need to photograph it. It's one of the original spiral nebulae back when there was a debate as to whether these were actually external galaxies or just spiral-shaped nebulae within our own galaxy. They are, of course, external galaxies, 50 million light years away for M51. It has this nice spiral structure. You see all these red star-forming regions like the Eagle Nebula all along the spiral arms. And you see this spiral arm and dust go in front of a companion galaxy interacting with M51. You can tell that the companion galaxy, I think, is behind M51. It's not exactly in the plane of M51 because it looks like that dust structure goes in front of it. But if we had a starship, we could try to fly around and look at it from the side. And I think if we looked at it from the side, we'd see that this system really, from the side, looks something like this. This is a flat, this is the plane of a spiral galaxy. It's spiral arms. You can almost guess that these are spiral arms inside here. And this is a companion galaxy that it's interacting with along the side. So I think this is the side view. This is the face-on view for systems like this anyway. We can't really fly around them in the Starship, but we can figure out what they look like from a different perspective. I have actually forgotten, and don't see in my notes. Oh, is this 1543? The galaxy in the river, this is an NGC, has an NGC number. It's a bright galaxy, but it's in the southern hemisphere, not in Messier's catalog. It's in the river, it's in the constellation of the river. It's in Eridanus, if you were a fan of the southern sky. I may
Is anybody still on? Looks like we lost about half of our group. Can you hear me?
I'm still on.
I'm still on.
It's another, we're 40 some odd minutes into a 107-minute video.
We're still on.
That's what I'm asking. Do you want to stay, watch it, or do you not?
It's up
Yes,
to you
no?
guys.
Just
I may have to get off, but suit yourself.
All right. Those of you who are on, you still want to listen?
It's okay by me.
Yep.
Okay, I'll see if I can get her back up here again. Whoops. Okay, we're 44 minutes into it, so about halfway through.
Don, I'm
Live
getting
through here
I'm
pretty
getting
fast.
some
We're
dark.
obvious-
Do what?
I'm getting some dark rectangles up at the top of your screen. They're just grayed out.
Okay. There's a beautiful picture of Kathy.
Oh. And my Miracle Grow roses.
Yeah, those things are healthy. Last time I saw them. Oh, let's see. I want to do a screen share. What does that look like?
There's still a small one, but okay, it's gone.
Yeah, the small one I think is the speaker's screen.
Obviously, visiting, we're obviously in extragalactic space here. This is a famous image of Messier 101 from the Hubble Space Telescope. It's a very high resolution image of the galaxy at its full resolution from a 2.4 meter telescope in low Earth orbit. And this is a pretty high resolution image of Messier 31. The galaxy's a little closer. It's about 10 times closer than M101. But this image, what M101 was imaged by Hubble from low Earth orbit. This was imaged by Robert Gendler from his driveway in Connecticut with his 12-inch Cassegrain telescope. I don't know. I enjoy the comparison between the amateur work and the professionals. We've moved out a bit. Now I think we're closing in on as far as we can go here. Galaxy cluster Abell 370. 4 billion light years away. Galaxies come in clusters, by the way. Where's a good place to find a galaxy? If you look out into the universe, the answer is right next to another galaxy. They come in clusters. They come in these large groupings of galaxies, which you see all together if you can look out far enough. The cool thing about this image is you're actually seeing beyond this galaxy cluster. You're seeing galaxies far beyond this foreground galaxy cluster, which is 4 billion light years away. The galaxies behind it are showing up as these streaks, these curved streaks. The gravitational mass of the galaxy cluster, Abell 370, is dominated by dark matter. And it's so massive that it's actually lensing. It's called gravitational lensing, predicted by Einstein's general relativity about 100 years ago or so. Anyway, we're looking, because of gravitational lensing, the cluster Abell 370 is acting a bit like a telescope lens, showing us light from galaxies far behind it, although stretched out into these long arcs. Spectroscopically, you can determine properties of those distant galaxies. So So thank you, Einstein and gravitational lensing. Okay. I think I probably will come to the end of the tour here. I had to work this in somehow. This is a slide this is an image submitted to APOD not too long ago that was one of my favorites. I guess this might fit into a terrestrial, a more terrestrial travel talk. Basically, the pixels are the moon, as you might have guessed. The moons, it's all natural colors of the moon. They're just pictures of the moon taken at different altitudes, different seasons, different phases, arranged into, like I said, pixels in an image. And you might recognize the image as the Mona Lisa, right? Which you would normally have to travel to the Louvre and to see. But here you go, the Mona Lisa. And the way to see, I think the way to see it most easily, you could stand back from your monitor a bit, or you could just look until at smaller and smaller images until you might actually recognize the Mona Lisa. The tie-in with Da Vinci that really impressed me was Marcella has used for the darker pixels here. The moon, that's the color of Earthshine, for example. That's the bright crescent moon, and this is Earthshine. When you can see the moon by light reflected from planet Earth, you can see the night side of the moon. Da Vinci actually explained what Earthshine was 500 years ago. So the Mona Lisa in Earthshine from Leonardo da Vinci. And the end, it says the end. Let's stop here. Let's stop here. This is it's actually an old image of the Chelyabinsk meteor flash. My goodness, that was in the Chelyabinsk meteor had an airburst over Chelyabinsk, Russia in 2013. Photographer out for a morning stroll happened to catch the airburst. I just like to end with that slide, Brian.
Well, that's a good place. You know, I don't remember which one it was. It might have been the DART mission, but a couple of months ago we had a webinar on. It probably was the DART mission about.
Okay, is anybody still there?
Yep, I'm here.
I think they've probably run our Zoom as long as we need to, but I'm glad you all could come on. And
I have just a quick question about the work day that you mentioned, John. And you said there's still more to be done. Like what is left to be done? If you know, generally speaking, off the top of your head.
I still need to get back out to the observatory classroom and do some arranging. I just ran out of time.
Okay.
There's between the bathroom and the hall classroom is some metal shelves with cleaning stuff. It just needs to be probably most of it thrown away. And I think James probably still got some outdoor stuff to do, but there's some indoor stuff left to do. Get it nice for our Messier Marathon coming up.
Okay.
Then some of us that are retired could do during the week sometime.
Some of us could. Does that picnic table that sits outside the building, does that need to be like sanded and painted? Or do people want that done?
It could use another coat of paint. I haven't used it in years, but
okay.
let somebody that looked at it more recently.
Okay.
Bob, you and Judy sit over there. What do you remember about the picnic table? I guess he's on. But yeah, there's some things left to do.
Okay, I'll volunteer to work on the picnic table.
Okay.
Uh,
I think James is looking at another work day, probably on a
Okay.
Saturday, but it's spring break for him and his daughter right now, so.
Okay, okay,
If I head out there myself sometime, I'll give you a holler, okay?
okay, sounds good.
All right, well, everybody, thank you for coming. I'm sorry it kind of ran sort of long, but we got some interesting pictures. So it's good to
Looks
see
nice.
everybody. So we'll see you again.
Well, it was good seeing everybody for a change again. I don't get out to the meetings very often. As you can see, I've got I got a monkey on my back here, so I stay in quite a bit.
Yeah.
Weather's been kind of bad too. I can't get out and do much here lately, but I'm still giving it a try.
That's good. That's a good thing,
Good to
Barry.
see you all. It is good to see you all.
Good to hear you, Tamara.
I
Thanks for
getcha.
your input.
Well, take care, everybody.
You
Bye-bye.
too.
Hey,
Bye.
Don, if you know anybody that uses ASCOM, I could use a hand with that. I'm having trouble on my Meridian flip.
Skip, I think, knows about ASCOM. But Skip Whitehurst, you can find him on our contacts page.
Okay, I'll send him a message.
Okey doke.
Thank you. Good night, everybody.
Over now.
Night.